the topic for this video is partial fractions. So partial fractions is basically about decomposing a rational function into a sum of two simpler rational functions. So for instance, well, it's based on this, idea that if you have 1/2 plus a third, say, it's equal to 5/6, right? And partial fractions is sort of like, how do you go from 5/6 to 1/2 plus 1/3? And so we're going to have to work with something like 7x minus 6 over x squared minus 3x. Well, x squared minus 3x has two factors, x and x minus 3. Well, what can you put as the numerators that will make you get 7x minus 6 in the numerator when you multiply it all out? So that's what this is about. And there's lots of different possibilities for the denominator. So let's talk about one of the cases. This is when the denominator, in this case, that would be the denominator in this example. If the denominator contains only linear factors, all of which are different. I'll probably make several videos for the different cases because doing it all might be too long. But this one is the easiest case. So in this case, the decomposition of the rational expression, right? Again, the rational expression just means a polynomial divided by a polynomial. So rational expression decomposition includes a partial fraction. So these are called partial fractions. It includes a partial fraction of the form a over ax plus b, where a is a real number. So let's look at this example, 7x minus 6 over x squared minus 3x. Well, the factors are x and x minus 3, so this is going to break up into a over x plus b over x minus 3, where a and b are constants. Now to solve for a and b, we can multiply both sides of the equation. So let's write out the equation one more time. 7x minus 6 over x times x minus 3 is equal to a over x plus b over x minus 3. One thing you can do is you can multiply both sides of the equation by the denominator. So if you do that, you're going to get 7x minus 6 on the top, and then so you distribute this x times x minus 3 across, and then the x, so for the a over x, the x's are going to cancel, so you're going to have a times x minus 3, and then plus, and then for this term, the x minus 3's are going to cancel, and so you're going to be left with b times x. And now you can distribute the a across, so you're going to get ax minus 3a plus b times x, and then you can combine the like terms and get ax plus bx, so that's a plus b quantity, okay, times x, and then minus 3a. So that's 7x minus 6. Now this is true no matter what x is, right? For all x, we need 7x minus 6 equal to the thing on the right. And whenever you have two polynomials that are the same, the coefficients all have to be the same. So if you look at, so we can match coefficients. So on the left, the coefficient of x is 7, right? And the coefficient of x on the right is a plus b. And since the coefficients are the same, we get 7 equals a plus b. Now we can match the constant coefficients. The constant coefficient on the right is negative 6, because this is 7x plus negative 6. So we get negative 6, okay, I'll use a different color. Negative 6 equals, okay, what's the coefficient, the constant coefficient on the right? Negative 3a. So negative 6 is negative 3a. So now we have this system of equations and we can solve. This second equation tells us that a is equal to what? 2. And so if you plug it back into the first equation, what do you get? 5, right? So we get a is 2 and b is 5, and that's what we needed to figure out this decomposition. So 7x minus 6 over x times parentheses x minus 3 equals 2 over x plus 5 over x minus 3. So that's the easiest case, and in another video I'll explain what happens in more complicated cases. So let's just do an application. So here's something that you might see in a calculus class. Let's say that you had to integrate 7x minus 6 over x squared minus 3x. Well, the thing is that substitution is hard to work with here, but I see that the denominator factors as x times x minus 3. So if I know that I can rewrite this thing as this, then I can rewrite the integral. So I'm integrating 2 over x plus 5 over x minus 3, right? And this is going to be the integral of 2 over x plus the integral of 5 over x minus 3. And then that's going to be 2 times the natural log of the absolute value of x plus 5 times the natural log of the absolute value of x minus 3, and then you have an arbitrary constant. So that's the answer. That would be the integral of 7x minus 6 over x squared minus 3x. So that's how partial fractions is used in calculus, and also partial fractions also show up in differential equations. When working with Laplace transforms. So this partial fractions, usually it's introduced in calculus when you get to integration, but actually this is just algebra, right? I mean, it's just, there's nothing about calculus involved in writing, 7x minus 6 over x squared minus 3x as a sum of two rational functions. Okay, so that's the easiest case. And maybe, let's just do one more. Not an example, but if you had something with distinct linear factors, but you had more than one or more than two, so like let's say you had, x minus a times x minus b times x minus c, then it's just going to be some constant over x minus a plus another constant over x minus b plus another constant over x minus c. And this is assuming that you have on the numerator degree 2 or less, right? Because you want the numerator to have degree lower than the degree of the denominator in order for it to work. Okay? So that's how you do it if you have, multiple factors that are linear on the bottom. And then we'll talk about what happens if you have like the same, so here A is not equal to B, is not equal to C. But you might have something like, over x minus 1 in parentheses squared, or x minus 1 in parentheses cubed. Then it will be actually different than what we have. So we'll talk about that in a different video.